Hey, Scott. Thanks for your questions about graphing quadratics. It's an awesome tool for us to be able to answer questions, and I appreciate these example questions that you've given me. This first one, we can see that we already have a graph, and the question asks us to show the height of the rocket, the initial height of the rocket. Initial height would be when our time has not passed at all, so when t equals 0. And you can see down on this x-axis, we have time right there. So t equals 0 happens right here at our y-intercept. The height is given by our y-axis. And so we can see that measured right here at this value of 216. It's measured in feet. So 216 feet will be our answer to that question. We can see how easy graphs make it for us to find certain key points, y-intercepts, x-intercepts, maxima, minima, those kinds of things. They're all really awesome uses of this tool. So these other two examples, we do not have a graph. And so if we take some time to be able to graph them, then we might be able to find some solutions easier. Now, in order to graph these, we need to be able to have an equation first off. So let's turn this into an equation. See, the difference of a square and a number is 36. Difference being subtraction, so we have some unknown number, and we're squaring it. That's our square of a number. And then 36, and we're taking the difference of those two, is equal to 5 times that number. So that would be 5 times whatever our unknown number was. Now I'm going to rearrange this a little bit so we can do some graphing with it. We're going to subtract the 5x from both sides so we can get this on the same side. So that gives us an equation of x squared minus 5x minus 36. And in order to be able to graph it, we should have a full equation with our y value on the other side. So I'm going to type this in as f of x equals x squared minus 5x minus 36. Now I'm going to show you a couple of tools. There are other ways to graph these, but tool number one I'm going to show you because this tool works for literally every type of equation that we have. We're going to pick some x values, and once we have some x values, we can plug it into this equation right here, and we can figure out what our corresponding y value is. So I'm going to pick x values of 0, 1, 2, and 3 for right now, and we're going to find out our y value. So we'll plug that into our equation that we just got. That first one would give us f of 0 equals 0 squared minus 5 times 0 minus 36. So we get f of 0, 0 squared is just 0, negative 5 times 0 is 0, so we end up with negative 36. And that gives us our first ordered pair. Let's plug in some other values. F of 1, we'll get 1 squared minus 5 times 1 minus 36. That'll give us 1 minus 5 minus 36 for a total of negative 40. We get f of 1 equals negative 40. F of 2 is next. We get 2 squared minus 5 times 2 minus 36. That would give us 4 minus 10 for a total of negative 42. And we'll do one more. We get 3 squared minus 5 times 3 minus 36. So we get 9 minus 15 minus 36 for a total of negative 42. And you can get as many of these as you want to put on your graph. Your graph will be more and more detailed the more points you get, of course. Let's go ahead and graph these now. We get 0, negative 36. So I'm just going to go 10, 20, 30, 40. Negative 36, so that'll be right about there. So 1 and negative 40 be right there. 2 and negative 42 be about right there. 3 and negative 42 would be right there. And we can see that our quadratic is following this shape. Sketch it out. That'll give us our rough shape of our graph. Now, that might not be enough detail, or it might not give us enough points. So you can add to the points right here, or you can look at our next method here, which might be a little bit more useful. Sometimes certain points are more useful than others, and we can see that with our y-intercept here. Our x-intercepts are often a useful point, and kind of help guide our other points that we're looking for. So we're going to find the x-intercepts for this by factoring. That would give us x minus 9 and x plus 4. If you're not sure how I did that, then go take a quick review about how to factor quadratic equations. This tells us that we find our x-intercepts where x equals 9 and x equals negative 4. And so if we take a look at this graph, we can see that my graph, the way I've drawn it, is a little bit off. Because 1, 2, 3, 4, that x-intercept should have happened right there. And then 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, our other x-intercept should have happened over here. And so we can now make some more accurate adjustments to this. We might as well keep our old points since we have them, but this is clearly off. All right, now that we have those points, we can be more accurate with our graph. One other point that is often of interest is this minimum right here. The minimum will happen halfway in between our two intercepts right there, which gives us an x value of 2.5. So if you were answering a question that would ask you what's the highest or lowest point of a particular situation, we now have a value we can plug in to right there to give us the solution to that. So there is one method of graphing. And one more thing I would add, when you're doing these x-intercepts, our y-intercept you can see was already given right here, which is a common one to look for. But if we hadn't gotten it already, then we just need to plug in that 0 for our x value. And that'll work on future equations as well. Let's use this next example question to show one more tool here. But again, we need an equation for this. All right, so we have length of a rectangle, we've got width of the rectangle, and it talks us about the area of the rectangle. So we know that area equals length times width on our rectangle. So area is 35 square units, so that'll be 35. And our length, it tells us, is the sum of the width and 2. So if I take the width and I add 2 to it, that gives us our length. The width will just stay w. I'm going to change these variables, the w's, to x, because that's what we typically use when we graph things. So if I rewrite this, I get x plus 2 times x and 35 over here. Now what we did before still applies. I want all of these on the same side of the equation so I can graph it with our y values. I'm going to subtract 35 to accomplish that. Subtract 35 over here, and we get 0 equals x plus 2 times x minus 35. I'm going to change this to our y value, f of x. And then over on the right-hand side, you can rearrange this, simplify it to your heart's desire, or you could leave it this way with the tool that I'm about to show you. So I'm just going to leave it this way so we can see that this format is totally fine. But again, if you want to rearrange it, you can. So another method to see is just to toss this into a graphing calculator. And some are a little bit pickier than others, but the one that I'm going to show you just allows us to type it in as is. So we're going to go to geogebra.org, and we're going to type in this exact equation. F of x equals x plus 2 times x minus 35. So here we go, geogebra.org, and we're going to type in f of x equals x plus 2 times x minus 35. And we can see it's got the graph. We can see here at -7 and here at +5, we find our x-intercepts. And if we want to find our y-intercept and our minimum, we can zoom in, zoom out. We can see our y-intercept there. We could see our minimum listed right there. We could get more points if we wish. If there's a particular point that you need, you can add it with this point tool along the graph, and it will list them out in your algebra menu. So if you need additional points, you can do that as well. Thanks again, Scott, and I hope this video was helpful.